So I'm going to welcome Oliver Morton from The Economist to talk about Luna and Gaia.
Thank you. Hello, am I on? Yes, good, great. Thank you very, very much. Heard a lot about Gaia, seen a lot of pictures taken from the moon. Where's my zappy thingy here? Ah, good, excellent. And so I said yesterday when someone asked that why I was interested in Gaia, I said that Jim and Gaia are the only things that turn up in all of the books I've written. And for some of them, that's pretty obvious. It's pretty obvious why someone who would write a book about Mars would write about Jim, because Jim wrote a book about Mars, and a rather good one. It's pretty obvious why someone who writes a book about photosynthesis that talks about its role in Earth history should mention Jim, because basically you're ripping off a lot of ages of Gaia. And geoengineering, it just turns out that an awful lot of people who think about geoengineering in Britain also turn out to be people associated with Jim and Gaia. So that covers three, but the moon, bit different, because the moon is, when it comes down to it, really not very like that. This is a picture from Discover, which is a NASA probe that hangs at the first Sun-Earth Lagrange point. So that's 1.5 kilometers directly towards the sun. Do not look for this satellite, because you will hurt your eyes. And that's the view looking back at the Earth and the moon. And as you can see, the moon is smaller. I mean, 75 million trillion tons, still quite a lot, 50 times the weight of the mass of the Earth's oceans, but still only a bit more than 1% of the mass of the Earth, an area roughly the same as that of a largish continent, bigger than Africa, smaller than Asia, but as you can see, really quite terribly dull. This is, of course, the far side of the moon, because you're looking down past the moon to the Earth, and you can really only see one feature worth mentioning, which is Moskoviense there, which we will actually come back to. That's one of the two lunar seas on the far side. But what's important about the moon, and the only reason that it's worth my while to have written a book about the moon, is what it tells you about both the Earth and about people from Earth who want to go places. And so, if the moon wasn't nearby, it would really be particularly uninteresting, but it is, and so it's worth thinking about, because people have been there and thought about it. But before that, let's do a little bit of composition. This is nothing. And it is also a fairly famous, this is a representation of nothing. This is a very famous picture. This is Casimir Malevich's Black Square from 1915. Malevich thought that he was and claimed to be, the first person who had ever painted a picture with no subject. So there is nothing central to this. There is no subject. There is nothing. And thus, because of the sort of person he is, Malevich is thinking it is also everything. But this is his great artistic statement. So there we are. Element one for our building, nothing. Element two, well, there's something there, but it's pretty unprepossessing. We get this sense that it's not nothing, it's a presence, but it's a presence and really nothing much more than a presence. Maybe it's actually even an absence. Could there be an absence and nothing? We don't know. This is Untitled, almost the last painting ever painted by Mark Rothko. He is at this time ill, depressed, drinking heavily, and suicidal. When asked what are these paintings about, he says, fairly predictably, death. So the presence there is, to some extent, death. But we look at this again, we turn it slightly on its side, and we add some glitter. And if anyone has been playing the Earthrise drinking game over this conference, you must be pretty drunk now, and you're going to be a lot drunker by the end of this talk. So here is Earthrise, taken by Bill Anders from, of course, over the far side of the moon. This is actually a little bit of a walled plain called Pasteur. And here's the star of the show. One of the things that's very interesting about this is that when people previously imagined what the Earth would look like from the moon, they tended to imagine it in the way that it matters to people in terms of politics. So they imagined it as an array of land masses and oceans clearly defined. It looked like a high school globe. It's pretty hard to know what the hell is on this picture, frankly. I mean, you know it's the Earth because you know where it's taken from. But unless you're pretty sharp, you won't know what any of it is, except possibly for this bit. This is the Western Sahara, and that little nubble there is a place called Ras Nordiju. And one of the interesting ironies of that is that that's one of the capes that is absolutely crucial to the early story of Portuguese exploration of the earth, or, as other people refer to it, the age of being explored by Europeans. Started around here, 1441, Nuno Tristão rounds this cape for the first time. Later, he becomes the first person to bring African slaves back to Europe. That's the one bit of Earth history you can see on this picture. So everyone says, oh, look how beautiful. Worth saying, moon quite beautiful too. This is a very similar picture, very similar orientation. Of course, the moons of the seas of the moon are dull rock, but it's still quite pretty. I don't think you can deny that just looking at it, it's quite nice. The difference is, you heard Jim this morning say that that Arthur C. Clarke once remarked that you shouldn't call it Earth, you should call it ocean, because if you look away, if you look from a distance, it's ocean you see. Clarke was wrong, for exactly the reason that those school globe illustrations were wrong. If you look from a long way away, you would call this planet weather, because that's what you see. And this gets to something that Gaia was bringing out yesterday, which is what you feel, what you intuit looking at this picture, is the extraordinary amount of change on the world. You don't really get a sense, I mean, you get a sense because you know. I don't think you can get a sense that you can feel it's alive, but you can feel that it's dynamic, that it's changing. There's something about the swirls that speak to the fact that sunlight on the moon is actually slightly more sunlight is absorbed on the moon than on the Earth. You saw that because, the moon's darker. But on the moon, all the sunlight you can pour on it heats up the top meter. And then at night, the top meter cools down, and then it does it again. This is dull. On the Earth, about 5% of the sunlight that comes in gets moved from the equators to the poles. Some of the sunlight evaporates off 16 million tons of water a second to create all those clouds. There is an unbelievable amount going on, and that's the message of looking back on the Earth and seeing how exciting it is, and it's even more exciting when you put the moon in front of it. And I am not the first or only person to have noticed this. That is my paperback of the first paperback edition of Gaia, and on page 64 you will find, thanks to what we have learned and are still learning about our planet from space research, the whole picture has recently changed. We have had a moon's eye view of our home in space as it orbits the sun, and we are suddenly aware of being citizens of no mean planet. However mean and squalid the human contribution to this panorama may be in close-up. Whatever happened in the distant past, we are undoubtedly a living part of a strange and beautiful anomaly in our solar system. Our focus has shifted to the Earth we can now study from space. So that's one of the reasons why someone who's interested in Gaia writes about the moon. But I want to get on to quantifying quite how useless the moon is. This is an illustration from a story by Robert A. Heinlein, the most important American author about the moon in the 20th century. It's from a story called Nothing Ever Happens on the Moon. The story means that slightly ironically, because the Eagle Scout involved in the story has to pull his mate back on a toboggan. It's all very exciting. But in fact, the purportedly ironical title is true. Nothing really does ever happen on the moon. This is from a paper by Peter Haff, who writes about the technosphere and the biosphere in terms of the amount of stuff that travels through them, which he measures using a measure called mass action, which is actually a pretty good measure for this. You can't see the details here, but here at the top, here's evidence for the Anthropocene. We were talking earlier about flows in the Anthropocene. Here you see that although the biggest flows on Earth are still, the material flows are still the great flows of the climate system, the flows driven largely by those 5% of the solar energy, you can start to see that things moved by humans, which are the black lines, are comparable. And then if you look in the middle tier, you see that whales, big up for whales, far and away the highest sort of like purely biological thing on this. Then you've got this whole slew of things that are done by humans, and then you start getting down to smaller things like volcanoes or caribou or tides, the moon's little contribution here. And then you get down to what I call the biotic rump of sort of like humans are the black line there. 2 below them you can see Stone Age humans who didn't move around so much. Tigers, I've no idea why tigers are on this list. So the question is, if with this list of mass action, where does the moon turn up? How much stuff is moving around the moon? It turns out that it's probably quite an easy thing to answer in that I've managed to convince myself I've answered it, and I'm not very good at answering things. So this is the process that moves things around on the moon. This is the crater Tycho. It is the only thing on the moon that you see with your naked eye that a dinosaur did not see with its naked eye. Everything else is unchanged. And incidentally, that there is Mare Humorum, which we will come back to later. So Tycho is about 100 million years old. It's about 4 kilometers deep, it's about 80 kilometers across, and most of the ejecta, although it's very obviously, some of it is spread out all over the place, most of it is within 1 radius of the impact site. So that gives you a way to calculate the amount of mass moved by Tycho. And since Tycho is the biggest, impact for 100 million years, and impacts tend to work by a power law, I'm going to say that that's all that's happened on the moon in 100 million years, and that's, true to a first approximation. And so there's lunar cratering. It's less important than landslides, slightly more important. That modern humans line is not everything modern humans do. It's actually just us walking around. So bigger than tigers, bigger than feeding birds, but not migrating birds. Lunar cratering, really, nothing is going on here. See this? These are the big Earth things. You see that they're more than 10 orders of magnitude more important than lunar cratering. The moon is, to every extent, uninteresting from the point of view of activity. So this is a paper by Adam Frank, Axel Kleiden, and Marina Alberti, which has been discussed already, I think, by Bron yesterday in 1 or 2 presentations in different places. This attempts to set up a hierarchy of planets, basically in terms of how interesting are they. Moon at the bottom. Hierarchy 1, there's no, P just means free energy here. There's no climatic free energy, there's no chemical free energy, and there's no biological free energy. The real message of the moon is that if you want to do anything, you need fluids. You've got to have stuff that moves energy around, that moves chemicals from one place to another, that disturbs equilibrium. You have to have flow. The moon, effectively, no flow. Here's something with flow, and already we're a lot more interested in Mars than the moon. If it wasn't for the fact that the moon is close, we'd be concentrating all human spaceflight interest on Mars, I suspect. It's got ice caps, it's got some chemical energy, not very much, it's got climate energy, and it looks pretty. This is Mars seen over the edge of the moon, but a photo taken by my friend Andrew Chaikin. You can see why, just on that picture, you can say, yeah, let's go to Mars, it looks nice, Mars. Here's another one. This is what they call in the Frank et al. Paper a thin biosphere. I fear that the drama of this picture has been slightly decreased by the fact it's already been used today. Here it is in context, taking its place over a lunar landscape, which is probably exactly the same then as now. This is the Earth about 3 billion years ago. And so it's the thin biosphere before the great oxidation event. Here's number 4. Here, this again, of course, is the Earth after the Great Oxidation event, and it is the Earth, and this is the place where we have climate, chemistry, biology, and a lot of biology that is interfering with, or certainly partaking in, climate and chemical free energy. So that changes through to our old friend again, drink. So there we have, I'm going to pretend that this picture was taken in 1868 instead of 1968 and say that this is a type 4 planet in their hierarchy in which the biosphere is strongly connected to chemistry and climate. This is the 5th hierarchy, this is where their hierarchy ends, a hybrid planet in which civilization, in the loose sense, is already making an energy contribution on a planetary scale, and those are the lights of North America. Yes, and I can see that. I think, oh gosh, really? And their problem is hybrid. Is this a hybrid with vigor? Is it a hybrid that will be sterile? Is this a hybrid that will die? We don't know. But they end their story there. I want to take it a little step further. Here we are 6. This is where things start to break down. Here we have something now, as you know, it's not powered by the sun, it's powered by a hyperreactor of some sort that I forget. It's smaller than most planets. But here we are, no climate, no chemistry, but we know that there are people on it. And we also know that sometimes what looks like a space station may in fact be a moon. What if you built power stations on the moon? I'm not advocating this for a moment. This is just getting to the end of the talk. This is where I justify having used lunar rather than the moon. So what would this be if you imagine putting 10 terawatts of solar panels, and I've actually put them on there, but you can't, but they're there. That's Mare Humorum again. If you put 10 terawatts of solar panels on the moon, that's equivalent to all the energy that human civilization uses. No climate, very, very little biochemistry. What sort of world, there it is in context again with a little thing. What sort of world would this be? I don't think we have the faintest idea what a world is like when it is a lunar, where there is a human presence that is entirely intentional, but not at all Gaian. Because there is no need to invent an atmosphere. You all live in tunnels. How bad is it? Or how good is it? Because, we talk about spaceship Earth. I hate talking about spaceship Earth, but the very way I introduced it tells you that this is spaceship Moon. So what would it be? What would the politics be of living in a place where everything was under either collective or possibly worse, independent human control? What would that be like? What are the, and that's a way of turning back on ourselves, the question of what are the politics of Gaia? What does it mean for how humans organize themselves politically that they are a part of Gaia? And one way to answer that question, I'm not going to do it, I'm going to ask you to do it as you take these ideas away. What would a world be like that had no seals behind the kayaks? What would a world be like where it was inhabited but not habitable? Those are the questions that the moon really poses to us. How much of our experience of the Earth is based on the idea that if we have the privileges and the risk-taking ability, we can walk away and breathe and forage and go? That's something that if you don't have Gaia, you don't have. What are the implications of understanding? Does Gaia bring us individual freedom but civilizational constraint? And what would it be like to live on Luna, where there is no individual freedom? If you walk out on the surface, you boil in 30 seconds. There's just nothing there. So that's what I wanted to ask you by asking you to think about Luna as well as Gaia. And just very, very quickly, I'm going to finish off by saying change. Change is important. Oh, there are some pictures of Luna. Nice. Change is important. Changelessness, changing. And I've been kind of saying that change matters, that change is good, but change also has a melancholy side. This is a painting by Thomas Cole showing the Earth rising above, the moon rising above the Earth, rather than the Earth rising above the moon. It's from this painting, which is called Desolation. And it's part of a series of artworks which asks us to contrast the changelessness of nature with the changing nature of humans and politics. Here's the early stage. You can see all these people, the frolicking shepherds and everything. It's all very, very jolly. You can also see this precariously balanced boulder, which obviously is just about to fall over. Here's civilization doing its stuff. Again, boulder, just about to fall over. And yet, big change in humans, no change in nature. Oh dear, those humans are at it again. Here's destruction. Boulder, still there. And here we are back at desolation. Boulder, still there. Nothing matters, Thomas Cole is telling us, in the human sphere when you look at it in the condition of nature. That's absolutely the way that we can no longer think. It's a fundamental tragic basis of our thought at the same time. But there's one last little surprise, which I only noticed when I saw this picture in the National Gallery recently. If you zoom in, if the attendants will let you, if you zoom in on the man in the moon, he's actually winking. So within the tragedy, there is at least a bit of a joke. I think Jim would like that. Thank you very much.